In this video, we're going to talk about balancing chemical equations. Sometimes I start out teaching balancing chemical equations by teaching how to balance the equation for a sandwich. If we have bread and salami and cheese, you can make a salami sandwich. But you have to, if you're going to balance this recipe equation, you have to be sure you have the same amount of stuff on this side that ends up in this side. Or you'll have things left over, and that's not the way this works. So if we read through this, we can say that we have one piece of bread on this side, but two pieces of bread on this side. So it's a problem. We found our first problem, and we're going to solve it. We're going to solve it by putting a big 2 in front of this piece of bread. Now we say we have two pieces of bread. Two pieces of bread here and two pieces of bread here. We've solved that problem. Now we're going to see if we can find another problem. I have a piece of salami here and one piece here. That makes sense. I have a piece of cheese here and one piece here. That makes sense. So this has been a really easy equation to solve. I have the same amount of ingredients on this side as I have in my finished sandwich on this side, and now my equation is balanced. So let's go on to balancing the equation for water. H2 plus O2 react to form H2O. You'll remember from our discussion of covalent bonding that there are some atoms that do not exist all by themselves ever in the universe. Hydrogen and oxygen are two examples of that kind of atom because they're not stable. They have to covalently bond with other atoms in order to be stable, and that's how they hang out in the universe. So H2 plus O2 react to form H2O. This is a true statement, but it's not a balanced equation. And if you look at it, you can see why. We have two hydrogen atoms on this side and two hydrogen atoms on this side, but we only have one oxygen atom on this side and two here. So we have to add some numbers to make this balance. Now, at this point, I want to remind you that when we're balancing equations, we can never change the small numbers within the chemical formula. The reason is we don't get to decide how molecules fit together. In the case of water, we'll draw this again. We drew it on Friday when we reviewed together. In the case of water, it's easy to see why. So we'll do this as an example. Oxygen, it has 6 valence electrons. Hydrogen has 1. Now, in order to be stable, hydrogen wants 2 in order to fill up its little small valence shell. So if it's near oxygen, it can say, hey, oxygen, can I borrow one of those valence electrons every once in a while? Oxygen says, yeah, sure, hydrogens, you can do that, but I want to be able to borrow one of your valence electrons every once in a while to fill up my outer shell. And hydrogen says, yeah, that's fine, no problem. And so now they're all stable. Hydrogen has full outer shells. Oxygen has a full outer shell. And so you can see that those three atoms fit together to make a molecule of H2O, or water. Now, if we were up here and we were saying, well, hey, this would be really easy if I could just balance this equation by adding a little 2 here. Now I've made H2O2. But that's not the same thing. And we don't get to make that decision. Molecules fit together in the way they do because of the laws of the universe, not because it's convenient for us to balance an equation. So I'm not allowed to do this, and I'm going to take my white out and make that go away. And the other thing is, I don't need to do that. I can balance this equation without having to add a little 2 here. I can balance it by making big numbers at the front, by making multiples of the molecules that really do exist. So we found the problem. 2 oxygens here and only 1 here. But if I say I'm going to end up with 2 whole water molecules, now I have 2 oxygens. The problem is I've made myself a whole nother problem. Now I have 4 hydrogens here and only 2 here. That's okay though. I can add 1. I can add a hydrogen 2 molecule here, so now I have 4 hydrogens, 2 oxygens and 2 oxygens. So now my equation is balanced. I'm in good shape. Now, let's go on and talk about iron oxide. Excuse the dog fur on my piece of paper. Hey Duke is in my office with me here at home. And he's been shedding, I guess. I didn't know he was up here. So I have iron and oxygen, which again is an O2 molecule. It reacts to form Fe2O3, which is rust. This is iron oxide. So let's find a problem and solve it. the first problem I see is pretty obvious. I see 1 iron here and 2 here. But if I add a big number here, now I've solved that problem. Now I see another problem though. Here's a O2, but this is O3. Now this is a particularly sticky sort of problem because this is an odd number. There's nothing I can do to this to make it equal that, because I have 2 here and 3 here. When that happens, the easiest trick I can tell you is to just multiply these two things together and make that many of whatever atom you have. So 2 times 3 is 6. So I know I want to end up with 6 oxygens. In order to do that, I can put a 3 here and a 2 here. Now I have 6 oxygens. I have 6 oxygens. The problem is that now I've made myself too many irons. Now I have 4 irons. I can go back here. Let me get my white out and make 4 irons. Now let's double check and be sure this is balanced. 4 irons, 4 irons, 6 oxygens, 6 oxygens. Looks as if we've just balanced the equation for iron oxide or rust. Here's a third example. This is kind of a cool experiment to do, or demonstration to do. We didn't do it in class this year, but we did last year. Pennies are made of zinc primarily. Newer pennies, at least, you can scrape the outside copper coating off of them and there's zinc underneath. So if you do that and you put a zinc penny in some hydrochloric acid, a reaction occurs. A lot of bubbles form. Those are hydrogen gas coming off, and the zinc replaces the hydrogen to form zinc chloride. The effect is that the zinc just kind of goes away and you're left with this copper coating that's just laying in the bottom of your beaker. It's very, very cool. We'll do it next spring if we have time. Y'all remind me. So let's balance this equation. Let's find a problem first. 1 zinc, 1 zinc. That looks good. 1 chlorine, 2 chlorines. That's not okay. So here we have a problem. We also have H2 here, but only 1 H there. So let's start with the first problem we found, 2 chlorines here. If I add a 2, I've balanced for chlorine. And I've accidentally, while I was at it, balanced for hydrogen as well. And that's all we have to do to balance this equation. We can go through it again just to double check. 1 zinc, 1 zinc, 2 hydrogens, 2 hydrogens, 2 chlorines, and 2 chlorines. This equation is balanced. Now, if that doesn't work for you, be sure and remember that you can make yourself little drawings. You can make drawings like this. We did this in class. You can add things. I'm just doing this as sort of a jog your memory. We did a lot of this in class when we were learning to balance equations. I also have those models that we cut out that you can use after school on Monday to review if you'd like to. And please remember, there are lots and lots of good videos online, better than this one, in fact, much better, that you can use to refresh your memory and relearn how to balance chemical equations. Don't hesitate to Google for this. Khan Academy especially has a series of really excellent videos about this. There will be 3 equations that need to be balanced on the final, 2 simple ones and 1 more complicated one. So please be sure that you remember how to do this before taking the final for physical science.